Video, I am going to explain preparation and properties of ethylene or ethene C2H4. Methods of ethylene. Number one, from ethane. Ethane on partial reduction with dihydrogen in presence of Lindar's catalyst. Pelladized charcoal is called Lindar's catalyst. Gives alkenes. Here you can observe acetylene or ethane reacts with hydrogen molecule, each hydrogen molecule added to each carbon. Then triple bond becomes double bond. CH2 double bond CH2 is formed. So here we are prepared ethylene or ethene. Ethene is a UPSC name. Ethylene is general name. Next, dehydrohalogenation. Alkyl halides on heating with alcoholic potassium hydroxide eliminate one molecule of halogen acid to form alkenes. This reaction is known as dehydrohalogenation. D means removing. Hydrohalogenation means hydrogen and halogen. When ethyl halide reacts with alcoholic potassium hydroxide gives ethane. Ethene. So here ethyl halide CH3 CH2X, where X equal to halogen, chlorine, bromine or iodine. So here, fluorine not participated in this reaction, so we don't use fluorine here, only chlorine, bromine and iodine. Alcoholic potassium hydroxide, ALC means alcoholic. So this hydrogen and halogen, the carbon which contains halogen is called alpha carbon. The next carbon is called beta carbon. So hydrogen removed from beta carbon. Hydrogen and this halogen to form hydrogen halide. Here hydrogen has less electronegativity and halogen has more electronegativity. So therefore this hydrogen leaves this bond and this halogen takes this bond. This bond becomes double bond between two carbons. CH2 double bond CH2. So this is ethene. So we are preparing ethene. We are understanding the methods of preparation of ethene. So this in the brackets also you can read beta elimination reaction. Beta means the hydrogen removed from this beta carbon. The hydrogen eliminated from beta carbon. So therefore this reaction is also called beta elimination reaction. Okay, next moving to the third or ethylene. Dehalogenation. Viginal dihalides on treatment with zinc metal lost a molecule of zinc halide to form alkenes. This is known as dehalogenation. D means removing, halogenation means halogens are removed. When 1,2 dihaloethane reacts with zinc dust gives ethane. ethene, sorry, this is also mistake, ethene, not ethane, ethene. So here CH2X dash CH2X. Viginal dihalides. Viginal dihalides means the halides which contain two halogens adjacent carbons, side by side carbon, adjacent carbons. These are called viginal dihalides. So here we take 1,2 dihalo ethane. So on heating with zinc dust, these halogens are combined together with zinc to form ZnX2, zinc halide. So I already told you X means chlorine, bromine or iodine. You can take anything here. So therefore this bond becomes double bond between these two carbons. Therefore CH2 double bond CH2, or you can say C2H4. This is a structure of ethylene. Ethylene or ethene. Okay. So moving to the next preparation. So here dehydration. Alcohols on heating with concentrated sulfuric acid form alkenes. This reaction is known as dehydration of alcohols. When ethyl alcohol reacts with concentrated H2SO4 gives ethene, not ethane. So in these three methods we have mistake, ethene. Okay. Let me explain this equation. Here I take C2H5OH, ethyl alcohol. This is the structure of ethyl alcohol, CH3, CH2OH. So the carbon which contains OH group is called alpha carbon. The next carbon is called beta carbon. Here one hydrogen from beta carbon and OH from alpha carbon removed when this ethyl alcohol reacts with concentrated H2SO4. So therefore H and OH as formed H2O, and this bond becomes double bond between these two carbons. This is CH2 double bond CH2 or C2H4. Okay, ethene. Next preparation. Next chemical properties of ethene. Number one, addition of hydrogen. Ethene add up hydrogen gas in presence of nickel to form ethane. So here ethene, CH2 double bond CH2, we are understanding the properties of chemical properties of ethene. So one reactant must be ethene. So ethene reacts with hydrogen. These are all addition reactions because ethene is unsaturated hydrocarbons. Unsaturated hydrocarbons always participated in addition reactions. So ethene plus H2 gives rise to these two hydrogens combined with these two carbons, and you get CH3 dash CH3 ethane. Okay, the next one, halogen. When ethene reacts with bromine, so these two bromines, one bromine added to this carbon and other bromine atom added to this carbon, so double bond becomes single bond. So CH2Br, CH2Br, 1,2 dibromoethane. Okay, the next chemical of hydrogen halides. When ethane reacts with hydrogen bromide gives ethyl bromide. Ethene is asymmetric alkene. So this hydrogen combined with this carbon and bromine combined with this carbon, double bond becomes single bond. We get CH3 CH2Br, ethyl bromide. The next one, of water. Ethene reacts with water to form ethyl alcohol. So here ethene CH2 double bond CH2. Water, I write water as H dot OH, H2O. In presence of a small amount of H2SO4 is taken here. Then one hydrogen added to this carbon on other OH group added to second carbon and double bond becomes single bond. It will become ethyl alcohol, CH3 CH2OH. Ethyl alcohol is formed. It is very important, ozonolysis. Ethene reacts with ozone to form ozonide and then it is converted into formaldehyde in presence of zinc and H2O combination. This reaction is highly useful in detecting the position of double bond. Let me explain the equation. Here, one reactant I already told you, this is the properties of chemical properties of ethane. So, ethene plus or ethylene plus ozone is O3. These three oxygens combined on either side of double bond. So, therefore, one oxygen on above the this molecule and two oxygens atoms are below the this like this. This is ethylene ozonide. When you after this ozonide formed, then we combined with zinc and H2O. Then this oxygen removed from this molecule and the bond between these two oxygen atoms are break. Then CH2O, 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 2 CH2O. CH2O means HCHO. We can also write HCHO. Formaldehyde is formed. So finally we get aldehydes in this ozonolysis. Very important reaction. Then polymerization, last one. Polythene is obtained by the combination of large number of ethane molecules at high temperature, ethene molecules at high temperature and pressure in presence of catalyst. The large molecules that obtained is called polymers. This reaction is known as polymerization. The simple compound from which polymers are made are called monomers. This is the polymer and this one is monomer. The simple molecule ethene is a monomer because the molecules which participate in polymerization is called monomers. So here we are taking ethene, n ethene molecules combine together at high temperature and pressure. Then this bond breaks, double bond becomes single bond, and that electrons of two electrons in the pi bond, one each going to each carbon, then it will form a big molecule. N is an suffix here, so polythene. So N is a big number. Okay, so ethene. Some of the in explanation I told you not ethene, ethane, not ethene. So be careful while you are take down the notes. Thank you.